welcome Professor Mohammed Mian McCower. Mohammed is currently an assistant professor in the software engineering department. He received his PhD in 2016 from the University of Michigan. His research interests include software quality, systems, refactoring, model-driven engineering, and software testing.
Thank you. So, good afternoon, everyone. I have just realized that me and Professor Matt have the exact same shirt.
Good taste.
And I don't know if this is a coincidence because we'll also talk about similar subjects. So he was raising the awareness about phishing and detection. I will also doing the same thing, but in the source code level. And I'm trying to raise the awareness about what are the dangers that face your source code that you have previously developed, that you're developing right now, and you'll be developing in the future. So to start with, software maintenance is a nightmare for developers. 67% of budget in companies is allocated right away to maintenance. And within this, developers every day, they spend 76% of their time doing maintenance-related tasks, such as debugging, adding new features, looking for bugs, and all these, within all this time, they spend 60% of their time just looking at the source code, trying to understand how it works. And with all this effort that we do every day, we still experience up to $3 billion of loss out of software bugs. As you can see, there is something happening here. Is this the fault of the developers? Not necessarily. So why software maintenance is so challenging? It's very simple. When you go to industry, what they care about, number one, is you should deliver. Delivery is the number one request, and as we all know, if you put time, cost, and quality into the picture, then you have to optimize two objectives, and you lose one, and guess which one they actually lose? You already know the answer. So to go with this, as we develop, we know what are the good programming practices. That's what we do here, that's what we teach you here as students. You're all familiar with concepts such as object-oriented design. You know how to write good code that is actually respecting design principles. You have seen probably, you're familiar probably with those kind of design principles that you apply every day. But when you go to industry, you're under pressure and you may need to take shortcuts to deliver. And you're good enough to do that, but by doing so, you're moving from the good programming practices to the bad programming practices. And by do so, you are moving from the design patterns that are good programming practices to the anti-patterns that may exist in the source code. Your source code still runs fine. It still delivers what the client wants, but it's not, the quality of the code is not good for you later on to update. Okay? So how do we define those anti-patterns or bad programming practices? Usually they are well defined as code smells also. They are introduced either when you are initially designing your software or when you are maintaining it, and mainly when you are maintaining it, because that's when you are under pressure to deliver. Also, they make your design of the software is hard to understand from the developer's perspective. So the software is still fine, runs fine from the client perspective, from the developer's perspective, it's hard for you to maintain it. Okay? And this makes software development is very expensive because you will experience a lot of bugs as you go, and your software is no longer good for you to be able to look at and understand. So you may think of multiple examples of what we call code smells. You have shotgun surgeries, feature envies, gut losses, schizophrenic losses, you name it. But I'll go with a very simple example for you to follow. Okay, so let's look at the duplicated code. Okay, so how many of you guys have already copy-pasted code from the internet? Almost every, okay, I'm going to reformulate this. How many of you have copy-pasted your own source code? Oh, now, okay, everyone did it. Okay, that makes sense. Actually, you don't have to be shy. If you have copy-pasted code from the internet, that's not bad, that's software engineering. It's not bad. It's okay. It's okay, as long as you're able to maintain it in the future and update it and make it run to your needs. It's fine, okay? But the problem here is this can become sometimes a bad programming practice. And here you have, for example, this example of, okay, you have this example of piece of code that I have to fix it twice because this piece of code delivers a functionality that I need somewhere else. So the fastest way to deliver is for me to copy and paste it here somewhere else. Who can tell me what's the problem? Okay, now I have saved time. On the short term, I was able to save time by, reusing this functionality. But in the long run, why this can become a problem?
If you want to change the functionality, you might change it in one place, but then forget to change it somewhere else.
Exactly. Does it make sense, guys? This is like the first intuitive thing you can think of. So you give this to code to someone else because you're working in a whole team, and this team is not aware of this copy paste. Okay? So they will end up probably updating this feature by changing this piece of code, but not this piece of code. Is this a problem that the compiler can detect? No. It's a logical problem. That's what happens. You ship this software, it doesn't work fine, you have a bug, good luck looking for the error. This is really serious. So to fix this, you can simply think about creating, for example, a method, and then put this piece of code in the method, and then just call this method here and here. Then when you want to update your source code, you go to the method, update the method, and this update will be reflected here and here, okay? So this is probably a very simple problem, but we have, of course, more sophisticated errors that require much more effort from the developer to do to maintain a good code base. And unfortunately, this effort cannot be measured by managers, okay? So usually when you refactor your code and restructure your code, this is invisible to the client. So how would you convince your manager that you're doing a good thing by implementing those kind of good programming practices? It's tough. That's why you take the shortcuts and you move on. Let me give you an example of what happens if you keep taking these shortcuts and you don't care about the quality of your software. All of you guys are probably familiar with the Android or the mobile environment, and everyone is crazy about writing, for example, messengers. We have Google Messenger, Facebook Messenger. A lot of messengers are out there, so you can also make your own messenger right now. It will take you probably, I know that all of you are good developers, it may take you a day or so to build a function like a messenger which has a text chat and friends list. Very simple, you ship it, you have users, you're happy, you start making money, your company is going fine, everything is good. What's going to happen next? Facebook Messenger and Google Messenger right now, they are implementing the voice communication. So you have to, if you want to compete with them, you have to implement those kind of features as well. So you start adding features to your software. You may become familiar writing source code like this, but adding, for example, voice communication might require a little bit of expertise that is out of your area. So you start moving your source code from an area that you are comfortable with to an area that you're uncomfortable with. You're testing a new feature, okay? So your state of the code right now is under test. This will add a bit of stress in the team. As you go, so you start experiencing some kind of performance issues such as execution time. Your app is taking longer than you expect. It consumes more battery. That's because you're not comfortable with the new features in your source code, and you are not really knowing how you do this. So you end up also trying to fix, or try to understand how to optimize this. We are all made, we learned how to approach these functionalities and to write them, but we are not really, made or trained to how to approach such situations, okay? So as you go, you experience also some new problems. You have some crashes. Your software leaks. How do you fix this? How do you debug this? Now you have a new software with an unstable state, with a new feature, having issues, and also it's leaking. And within all this being into the picture, there is a new iOS, new update in the Android or the iOS, and you have to migrate all your libraries. Your project is basically dead. Everyone just gave up. If you may think this is not really a trivial, or you may think this is a very pessimistic example, if you think about it, it's not really the case. Okay? Google, if you go to the app stores, they usually show you the highest rated apps, the most used apps, but if they show you all the apps, then that will look like a cemetery of all the abandoned and dead projects. So I want you to be careful with that. Okay? So my research here is trying to help the developer be comfortable with what they do. So I want you to be able to work on things that you are comfortable with, and let the computer handle things that you are not comfortable with. Which means I'm trying to detect all the problems in the source code and automatically optimize them by changing the state of your source code in a way that respects all these different criteria. And I do this, and I've been doing this by source code transformation. So I've been working on automatically transforming source code to optimize the quality. I do this by using artificial intelligence algorithms that are able to take multiple objectives and criteria, such as the good design, you can go for power consumption, memory leaks, etc. And then this will allow the developer to work on things that they are comfortable with, while my software is running in the background and fixing things that they are not familiar with. And then, of course, if you want to try this, please come later to my demo and bring also your source code. Bring your C++ projects, your Java projects, and I can help you look at problems in your source code. Thank you.
As Professor Howard mentioned, he is going to be demoing at our reception afterwards. I hope you stop by his table, but we have a couple minutes for questions. Does anyone have any questions?
Would you say it'd be more effective to give this presentation or a single presentation to software development company executives and managers, just so they'll know that they shouldn't push their developers that much if they want to have, because they might say things now, but then it'll be hard to maintain for everyone later.
I'm sorry,
So would you say it's beneficial or more effective to give this talk to code executives, software development
Of
managers?
course, yes. And in research right now, we're trying to define this kind of, for example, situations by calling it, for example, technical debt. That's how much you owe the client, and you try to convince your manager, look, if you do this, then on the long run, you will end up saving a lot of money. And right now, we are raising the awareness through these kind of tools to actually help developers and managers realize how important it is to make, to give some time to developers to refactor, to update their source code. And also, we're trying to help developers by automating this process because it's still not really what they are meant to do. If you think about it, they are not comfortable doing it. Mm-hmm.
How is this different? How is this different than other static analysis tools like linters that kind of find, the obvious good practice?
That's a very good question. Those tools are code reviews. They look mainly at the source code level. So they look at violations in the source code level. This looks at the design level. So it's a much more higher level of problems that they are actually language independent. Okay? Well, you're right. There are some language-dependent smells that we can detect through code reviews. But if you look at more sophisticated problems, they are actually on the design level, so they are language independent, and that's also, they are known to be very severe. You're right.
Time for one more question. Do you have anything else?
If you have any other questions, please drop by. We can look at some code and we can see some problems. Thank you.
Thank you very much.